And this is independence in the multiplication rule. And for some definitions, two events E and F are independent if the occurrence of event E in a probability experiment does not affect the probability of event F. Two events are dependent if the occurrence of event E in a probability experiment affects the probability of event F. Okay, example that. I'm pulling two cards out. I'm looking at getting the probability of two kings. Okay, if the person pulls a card out at random, and so forth, the probability they're going to get a king is 4 out of 52. Now, they put the card back in. Then the second time when I pull a king out, it's basically the same probability because we still have the 52 cards. Now, compare that against, that's the independent. Compare that against if I take a card out and it's a king, and I take that and I set that card aside. Now instead of there being 52 cards, now there's 51 cards. So those are dependent. That's what they're talking about there. Now if you get independent events, and you got the probability of E and F, then it's equal to the probability of E times the probability of F. Now sometimes the and is implied. If I say what's the probability you're going to get 3 cards and all of them are kings. Well, what's implied there is the first card is king, and the second card is a king, and the third card is a king. So you may not actually see the word and in there. It's implied. What's the probability you'll get 3 of a kind? Well, that's, again, an and there. So, and this says can have more than 2 events. So you can have however many. Well, let's take a look at this first one. Probability of E is equal to 0.5. Probability of F is equal to 0.3. And it says E and F are independent. What's the probability of E and F? Well, from the formula we just looked at, probability of E and F is equal to the probability of E times the probability of F. So we're going to have 0.5 times 0.3, which gives us 0.15. Now, what this notation indicates, we've talked about a little bit. And again, here's A and B, but you can have any letters there. Probability of A and B equals probability event A occurs in the first trial and event B occurs in the second trial. Let's take a look at finding a probability. It says what is probably rolling a die and getting a 5, and flipping a coin and getting heads. So 5 on a die and heads on a coin. Well, me rolling a die has nothing to do with flipping the coin. So these are independent. Now we look at the probability of getting a 5 on a die. There are 6 faces on a die, and one of them is a 5. So that'd be 1 6. Now for heads on a coin, well, there's 2 possibilities, heads and tails, and of those, one of them is a heads. So we get 1 6 times 1/2, which gives us 1/12. And put those into decimal form, put them into fraction form, whatever's appropriate. When I say whatever's appropriate, the book, if they have it in decimal, you can put it in decimal to check your answer. Comes test time, what I'm looking for is a setup, because I want to make sure you know how to set it up. Sometimes you can work a problem wrong, and then you look at the decimal, and with rounding, maybe you still come out correct. And again, I'm interested in whether you understand the setup. Okay, our third one. Given the probability you're going to die from cancer versus other causes is 0.23. And I actually looked this up on I think it was CDC's website. And it is 23%. What is the probability that 4 people picked at random are going to die from cancer? You'd be surprised. The one that's largest is heart disease. And statistics are funny, and I like to mention this because my mother passed away last December, and she went to bed. She'd been sick, had a flu or a cold or something, and when they went in the next day, she had passed away during the night. Well, they didn't do an autopsy, and they're not quite sure, what happened when I asked them. When I got the death certificate back, the cause on there was heart disease. I was told that, or not told that. I saw it on a show one time that if they don't know what caused the person's passing away, they just put down heart disease. So it's kind of deceiving when you see up there and it has heart disease so high. Granted, no matter what happened, it caused her heart to stop. That doesn't necessarily mean heart disease. But anyway, I go off on a tangent on how people abuse statistics. Okay, what is probably if 4 people picked around going to die from cancer? So 4 people die from cancer. Now what this means is the first person dies from cancer, and the second person dies from cancer, and the third person dies from cancer, and the fourth person dies from cancer. So there's implied ands in here. So it's multiplication. Well, the probability that one person is going to die from cancer is 0.23. So we're going to take 0.23 times itself 4 times, because we've got 4 people. Now another way of writing that is 0.23 to the 4th power. Now to show that in the calculator, if you're not very familiar with exponents, no matter what, if you're in something you're not sure what it is, just do a second mode that gets you out. Okay, we do 0.23, and you do caret, and then 4, and enter. And that gives you your probability. So 0.0028 would be our probability. Let's look at our next problem. It says we're rolling a pair of dice. What is probably that we get a total of 7, counting the dots 4 times in a row? Well, let's talk about dice first. This is the problem. Problem is that. Oh, I skipped one. Sorry. Okay, problem 4. Given a standard deck of cards and we pick 3 cards out with replacement, that means we pull out a card, we look at it, and then we put it back in. What is probably getting 3 kings? Well, that means the first card's a king, and the second card is a king, and the third card is a king. So the and's there, it's multiplication. These are independent because I'm putting a card back in the deck. So first time through, there's 52 cards, and there's 4 kings. So the probability I'm going to get a king is this. Okay, so I envision this. I got a king of hearts. I pull it out, I look at it, that's nice, and I put it back in the deck. So there's 52 cards again, and 4 of them are kings. Pull out another king, look at it, think that's nice, put it back in. So I got 52 again, and 4 on top. And where's my calculator? There it is. 4 divided by 52, caret 3. That's interesting. When I plugged in my calculator, I couldn't have asked for a better time to show this. I get this right here, and I'll round it to 4 decimal places. What this is scientific notation. What this means is e to the negative 4 means move your decimal point 4 places to the left. So our answer is actually 0.00045517. And if I were to round it to 4 decimal places, that'd be 0.0 3 zeros and then a 5. Let me save this. What is this called? Independence and the multiplication rule. multiplication rule. Page 01.pdf. There we go. Now let's look at problem number 5. Okay, we're rolling a pair of dice. What's probably we get a total of 7. Total of 7, 4 times in a row. So first time would be a 7, second time's a 7, third time's a 7, and the fourth time's 7. So there's an implied and there, isn't there? Okay, let's talk about the different possibilities. You could have first die has a 1, second has a 1. First one has a 1, second one has a 2, 1 3, 1 4, 1 5, 1 6, 1 7. Then it could be 2 1, 2 2, 2 3, 2 4, 2 5, 2 7. I better go to bed. Okay, never mind that. These are not the droids you were looking for. Now, as I list the possibilities, I keep going here. What we're going to find is that there's a total of 36 possibilities. Now, specifically, see how we got 1 2 here, and then we got 2 1 here. Getting a 1 on the first die and a second on the second die, or a 2 on the first die and a 1 on the second die, those are 2 separate events. But the 1 1 only occurs once. So keep that in mind. Okay, so let's go back to here. We're looking at getting a total of 7, so a sum of 7. Think what could give you 7? Well, 1 and 6 would. 6 and 1 would. 2 and 5 would. 5 and 2 would. 3 and 4 would. And 4 and 3 would. Those are all the combinations that added together to give you 7. Now there's 36 total. And 1, 2, 3, 4, 5, 6 of these. So that's 1 6. Now here, that's for that's for your possibility on your first roll. We got 3 other rolls where we're going to get 7. So this will be 6 out of 36, 6 out of 36, and 6 out of 36. Now these are 1 6. So that'd be 1 6 to the 4th power, which would give us another scientific notation. 7.716049383 e to the negative 4. Again, we'll move our decimal place 4 places to the left, and we get 30 7716049383. And rounded to 4 decimal places, we get 3 zeros, and then an 8. And that would be our possibility. Now, the next one talks about the least 1 probabilities. This is of the form when you got a problem that says find probability of at least 1 something out of n. And it could be anything there for the something. First step is write as 1 minus probability of none something. Then write as 1 minus probability of all opposite of something. And 3, write as 1 minus probability of all and then opposite of something to a power. So let's look at this. I'm going to do this example. Out of 5 births, find a probability of at least 1 girl. So at least 1 girl out of 5 births. Okay, let's go back up here to our form. First says to write this as 1 minus probability of none or no, and then whatever we're talking about. The something, at least 1 girl, this will be our something, the girl. So none girl, no girls. Maybe that'd be better to math or English-wise to say that. Remember I said none or no. So 1 minus probability of no girls. Well, then we rewrite it as 1 minus probability of all. So the no or none changes to all. And then we go the opposite of girls. See, we got something here, and this is opposite of something. So opposite of girls is boys. And then down here we're going to put the power on there. When we say a probability of a boy, we look at one child, and the probability to get a boy is 1/2. And now we're talking out of 5 births, so that's what determines what our exponent is, how many we're talking about. And if I were to put this in my calculator, 1 minus 1 divided by 2, carry it to the 5, we get 0.9688, rounding to 4 decimal places. So if you're going to have 5 children, the probability you get at least 1 girl is pretty good. Let's look at our 6th example here. Test contains 25 multiple choice problems. So 25 multiple choice, each with four parts. So I got 4 parts, like an A, B, C, and D. Only one of which is right. One of which is right. Means the other 3 are wrong. You're guessing. What is the probability you get at least 1 right? Okay. So at least 1 right. And you're guessing on every problem. And let me put that here. At least 1 right out of 25. Okay. Look at our steps here. We rewrite it as 1 minus probability of none something, or no somethings. And in this particular problem, at least 1 right. This is our something. So at this point, it just carries straight down. So 1 minus probability of none right. Now then we change it to all, and we change the something to the opposite of something. So this is going to be 1 minus probability of all, and the opposite of right is wrong. Now you want to keep this really simple. Even if you got it really wordy up here and at least 1, try to choose a 1-word description that sums it up. Because then when you flip it to the opposite, it's a lot easier to flip. Even if you're technically a little bit off, just as long as you can get it to 1 word. Okay. Let's look at the probability for one question that you're going to get it wrong. Well, if there's 4 parts and one of them is right, then the probability you're going to get it wrong is 3 out of 4. Now there's 25 questions, so that's going to be our exponent. So we'll have that, which gives us 1 minus 3 divided by 4 caret 25. Then rounding to 4 decimal places, I got 0.9992. And that'd be our answer. Let me save that, and let's look at our last problem. Okay, number 7. The odds you will die from fireworks is 1 in 652,046. They compile all this, so you're going to die from fireworks is 1 out of 652. I don't remember where I got this one at. Some kind of government website. That. It says, what is the probability that out of 5 people picked at random, at least 1 will die from fireworks? So we're looking at a probability at least 1 will die. Out of, how many are we looking at? 5 people. Well, first thing we do is we write it as 1 minus probability of none somethings. And our something will be the die. So 1 minus probability of none die. Well, next part we change none to all. And we change die to the opposite of it. So all live. Okay, let's talk about probability somebody's going to live. If they're going to die from fireworks as that, then the live will be 1 minus that. That's the complement rule. Now you could put that, actually put that inside the parentheses if you want, but we'll go ahead and simplify it. That'll give us 652,045 over 652,046. If one of them is going to die out of that many, then this many will live. So we'll have 652,045 over 652,046. And out of 5, so the how many goes as your exponent. So let's see what we come up with. So 1 minus 652,045 divided by 652,046 caret 5. And we get 7.66814713 e to the negative 6. This is the problem with rounding to 4 decimal places. This e to the negative 6 means I move my decimal 6 places to the left. So I'd have 1, 2, 3, 4, 5, 7, 6, 6, 8, 1, 4, 7, 1, 3. If I were to round this to 4 decimal places, it'd be 0. Probability would be 0. I'm going to take it out more. I'll take it out to 4 significant digits. So I'll take it out that far. I don't like how some books will automatically just round to 4 decimal places. It's better to go with significant digits. Instead of with significant digits, you ignore those leading zeros. And I think that's the last problem. Yes, it is. Save it. And stop the recorders.